In this video, we're going to learn about tangent. We talked about how sine of any angle is always the opposite over the hypotenuse. The cosine is the adjacent side over the hypotenuse. Well, now we can define tangent, which is just the opposite side over the adjacent side. So now looking at a triangle, looking at a right triangle here, if we were asked what's the sine of this theta, of this angle, the sine of this angle, well, we know that's the opposite side 3 over the hypotenuse of 5. And the cosine is going to be 4 over 5 because 4 is the adjacent side. And so now we could say that the tangent, though, for the tangent, the hypotenuse doesn't really matter. It's just the opposite side of 3 over the adjacent side of 4. So just 3 over 4 would be the tangent here. Now, there's a way to sort of memorize sine, cosine, and tangent and which one is which. If you think about it, the sine, you can call that S, is opposite O over the hypotenuse, H. And then the cosine is adjacent over hypotenuse, that's AH. So just like if you look at all the first letters of all these, and then similarly tangent is opposite over adjacent. T is opposite over adjacent. And so if you sort of say these out loud, it's like SOHCAHTOA. So that's it. If you've heard people saying SOHCAHTOA, that's what it is. It's a way to remember what the definitions are for sine, cosine, and tangent. So just to do another example, a little bit more practice with tangent, let's say we're given this triangle, this right triangle, and we're asked to find the tangent of each of these two angles, 20 and 70. So if we want to know what's the tangent of 20 degrees, well, first, let's keep in mind the opposite side to 20 is going to be B. So B, but then remember it's opposite over adjacent, right? So here, looking at this triangle, C is the hypotenuse, right? So if it helps, you could first label, all right, C is the hypotenuse, and relative to 20, B is the opposite, which means A is the adjacent one. It's next to it. So here it's just going to be B over A. But within that same triangle, if we were to look at a different angle, if we were to look at the 70-degree angle, now for 70, the opposite is going to be A. The hypotenuse is still C, though. So the opposite, as we said, is A. And now the adjacent, the one next to it, is B. So again, that's just applying tangent. It's really just the exact same procedure as sine and cosine, except now it's sort of like you're not using the hypotenuse as a part of it. You might be given, just going back to sine though, one thing to keep in mind is you might have tricky looking examples, like ones where the triangle isn't oriented like the way you're normally used to seeing them. Like here, for example, if you were asked what's the sine of this theta, this angle, well, then it's something to be like, all right, well, let's see, the opposite is 6 over the hypotenuse. You might think, oh yeah, that's 8, right? Because we're used to the hypotenuse being like that, right? Like here, we're used to the hypotenuse being this guy. But remember, the definition of hypotenuse is it's the one opposite to the 90 degrees. And here, 8 isn't the hypotenuse. The hypotenuse is actually this guy over here, 10. The one across from the 90-degree angle is 10. And it's also just the biggest sides. If you have all 3 of them, 10 is the biggest one. So either way, if you think about the sine of this angle, it's going to be 6, which is opposite over the hypotenuse, which is 10.